Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to solve quadratics of the form x squared plus bx plus c equals 0. This standard is covered in Algebra 1, 2, and pre-calculus courses. Don't forget there are 10 practice problems at the end of this presentation that we'll like you to work on in order to demonstrate mastery of the content covered in this tutorial. If you'd like to gain access to the entire playlist and the course and valuable resources, just take a look at the link in the description below, or you can visit our website at mathgotserved.com. Alrighty, the instructions for the examples that we're working on are as follows. You're to solve the given quadratic equations. Solve the given quadratic equations by factoring. Okay, there are other ways that you can solve a quadratic equation, but in this particular presentation, we're going to take a look at the factoring method. Okay, all right, so for number one, let's say we have the quadratic trinomial x squared minus 2x minus 8 equals 0. So let's go ahead and solve that by factoring. So we have x squared minus 2x minus 8 equals 0. All right, so first things first, let's see, is there any common factor that can be extracted from all three terms? We can clearly see that there's no greatest common factor that can be taken out. So we want to proceed to use the X-game factorization method to figure this out, okay? All right, so we're going to have AC. AC goes on top, B goes on the bottom. In this particular problem, A is 1, B is negative 2, and C is negative 8. A times C is negative 8, and then B is negative 2. So ask yourselves, which two numbers multiply to give you negative 8 and add to give you negative 2? All right, and they generate all the pair of factors that result in negative 8. Let's go ahead and put that up. So what numbers multiply to give you negative 8? We have, so let's just do 8. 1 times 8 is 8, and then 2 times 4 is 8, and that's basically it. So a combination of 2 and 4 will work here. So we have 2 and 4. And in order for the sum to be negative and the product negative, the bigger of the two has to be negative. Okay? And in this particular case, since A is equal to 1, we can skip factoring by grouping, and then we just jump straight to the factored state. All right, so let's just write that down. Since A is equal to 1, as we can see here, so we can skip grouping. And then just jump right to the factored state, which is x plus 2. That's this first number here. And then x minus 4 equals 0. Okay, now we're going to use something called the zero product property, which basically states that if you multiply two quantities, two unknowns to get 0, either one or the other is 0. Okay, so we're going to set x plus 2 to 0, and then x minus 4 to 0. Alrighty, and then solve both of them. To solve the first resulting equation, just subtract 2 from both sides, and then you have x equals negative 2. And then for the other one, you just add 4 to both sides, and then you have x equals positive 4. All right, so our solutions are x equals the set negative 2 and 4. All right, let's take a look at another example, number 2. Let's say we have the quadratic equation x squared minus 9x plus 18 equals 0. Let's go ahead and solve that by factoring. So we have x squared minus 9x plus 18 equals 0. So our A, as you already know, is 1, B is negative 9, and C is 18. There's nothing that can be factored here, so we're just going to jump right into the X game. and I'll factor this by grouping, okay? So AC in this particular problem is 18 and B is negative 9. All right, so what two numbers multiply to give you 18 and negative 9? We have 1, 18, 2, 9, 3, 6. That works. So 6 times 3. Let's fix the signs. In order for the sum to be negative and the product to be positive, both of them have to be negative, okay? And now A is equal to 1, so we're going to skip grouping again. So we can just write down what the factored state is. A is equal to 1, skip grouping. So we're now going to have the quantity x minus 6 times x minus 3 equals 0. Okay, now we use the zero product property. We'll set both factors to 0. And then we solve each of them. So for the first one, just add 6 to both sides. And you have x equals 6. And then for the second, you add 3 to both sides. And then you have x equals 3. So your solution here is 3 and 6. Okay. All right, let's take a look at question number 3. So for question 3, let's say we have the quadratic trinomial x squared plus 8x plus 7 equals 0, and we want to solve this by factoring. Okay, so we have x squared plus 8x plus 7 equals 0. There is no GCF that can be factored out, so we're going to jump right to the x game. So AC in this particular case is 7 and B is 8. So the two numbers that multiply to give you 7 and add to give you 8 is 1 times 7. Okay? So in this particular case, we know A is equal to 1. So we can skip grouping. So we have x plus 1 times x plus 7 equals 0. And then using the zero product property, we set both factors to 0 and solve. For the first one, just subtract 1 from both sides, and you have x equals negative 1. And then for the second one, just subtract 7 from both sides, and then you have x equals negative 7. So your solutions, there are two of them, are x equals negative 1 and 7. All right, let's take a look at question number 4. So for question 4, what if we have x squared plus 4x minus 32 equals 0? Let's go ahead and solve that by factoring. All right, so in this particular case, there are no GCFs that can be extracted. So we're just going to go right along and create our nice little x. We're going to play the x game right now. So AC is negative 32 and B is 4. So what two numbers multiply to give you 32 and add to give you 4? So we have 1 times 32, no. 2 times 16, no. 4 times 8, voila, that works. So 4 and 8. In order for the sum to be positive and the product negative, the small has to be negative. A is equal to 1, no need for grouping. We just jump to the factored state, x minus 4 times x plus 8 equals 0. And then using the zero product property, you set both factors to 0. Okay? And then to solve this, you just add 4 to both sides for the first one. To give you the first solution, x equals 4. And then for the next one, just subtract 7 from both sides to get the second solution, x equals negative 7. Oh, I'm sorry, subtract 8. I wonder where 7 came from. Subtract 8 from both sides, and then you get the second answer, x equals negative 8. So your solutions here are x equals 4 and it's going to be 4 and negative 8. Alrighty, so let's put it in order since we're using the set roster notation. Negative 8 and 4 are your answers to question 4. Alrighty, let's move right along. Let's take a look at problem number 5. Alright, so problem number 5 is pretty interesting. Let's take a look at that. So number 5, what if we have the quadratic trinomial given by x squared minus 3x minus 10 equals 0. Okay, so let's go ahead and solve that by factoring. So we have x squared minus 3x minus 10 equals 0. There's no GCF to be factored out here, so we're just going to use the x game to finish it off. AC is negative 10 and B is negative 3. So what pair of numbers multiply to give you 10 and add to give you 2? We have 1 times 10, which doesn't work. 2 times 5 is excellent. So 2 and 5. So to resolve the signs, the product is positive and the difference is negative. So the bigger of them has to be negative. Okay? All right, since A is 1, we can skip grouping, jump right to the factored state. X plus 2 times x minus 5 equals 0. And then using the zero product property, we set both factors to 0. And then you can solve this mentally. Subtract 2 from both sides, x equals negative 2. Add 5 to both sides, x equals 5. So our solutions to number 5 are x equals negative 2 and 5. All right, let's move right along. Let's take a look at question number 6. So for question 6, let's say we have the quadratic trinomial x squared minus 4x minus 45 equals 0. So we want to solve this by factoring. Okay, so x squared minus 4x minus 45 equals 0. We can clearly see that there's nothing that can be factored out, so we're just going to jump right into the x game. AC in this particular problem is negative 45 and B is negative 4. The two numbers that multiply to give you 45 and add to give you 4. 1 times 45 doesn't work. 3 times 15, that's 12 and 18, no. 4 doesn't go into 45. How about 5? 5 times 9, jackpot, that's what we want. 5 times 9. In order for the difference, the sum to be negative and the product negative, the bigger has to be negative. Okay. And then A is equal to 1, so you skip grouping and jump right to the factored state. Okay, using the zero product property, set both factors to 0. And then you solve. Okay, so subtract 5 from both sides here. You have x equals negative 5. And then this one, you add 9 to both sides, x equals 9. So your solutions for this problem are x equals negative 5 and 9. Okay, moving along, question number 7. So for question 7, let's say we have the quadratic trinomial x squared minus 6x plus 9 equals 0. Okay, so we are going to solve this by factoring again. All right, so we have x squared minus 6x plus 9 equals 0. There's no GCF that can be factored out, so we're just going to jump right into the x game. In this particular problem, AC is 9, B is negative 6. What two numbers work here? 1 and 9 doesn't work. 3 times 3, oh, absolutely. 3 and 3. In order for the product to be positive and the sum negative, both of them have to be negative. Okay? All right, so let's insert it back. So we have x minus 3. Remember, whenever A is equal to 1, you don't have to group, okay? Just skip grouping and jump to the factored state. Now what you notice here is that these two quantities are identical. So you're going to have a double root situation, okay? So we have x minus 3 equal to 0. Since they're both the same, you don't have to solve them multiple times. Just solve them once, and that will be your answer, okay? All right, so we have x minus 3 equal to 0 twice. So when you solve it, you end up with x equals 3. So this is how you write your solution. Since there are two of them, your solution is going to be x equals 3 with a multiplicity of what? Multiplicity of 2, basically saying that this shows up twice. Okay, all right, let's try another example. Number 8. Let's say we have the quadratic trinomial x squared plus 12x plus 36 equals 0. Okay, all right, we're going to solve this by factoring again. So we have x squared plus 12x plus 36 equals 0. So we're going to use the x game here, okay? If you look at what we have, you notice that there is no GCF that can be pulled out. So we just jump right into the x game. AC is 36 and B is 12. So what works here? 1 times 36 doesn't yield 12. 2 times 18, no, that's 20 or 16. 3 times 12 is 36. Can I get 12 from that? From 3 times 12, no. How about 4 times 9 is 13 or 5, no. And then we have 6 times 6 is exactly what we need. Now since a is equal to 1, skip grouping, we have x plus 6 times x plus 6 equals 0. Now using the zero product property, we're going to set both factors to 0. So you notice that this is just like the previous one. Okay, in the previous one, both factors were identical. So you just do it once, okay? So if you solve one of them, that's sufficient. Subtract 6 from both sides, you have x equals negative 6. This is known as a double root, alrighty? So our solution is x equals negative 6 with a multiplicity of what? With a multiplicity of 2, because this solution showed up twice in the solution. Alrighty, let's go ahead and take a look at the next one, question number 9. So for question number 9, let's say it's to solve the quadratic binomial x squared minus 13x equals 0. Okay, so let's go ahead and do that. So this is something a little bit different. If you notice, it's not a trinomial, so we're not going to use the x game here. You don't use the x game for binomials, just trinomials, okay? All right, but if you take a look at this, is there a greatest common factor that we can pull out? Absolutely. Check this out. If we break it down, what you notice is that x is common, okay? So we're going to factor out x and divide it out. So if you factor out x, you divide it out, x goes here 1, 1, and you're left with x minus 13. Okay, so this is the factored state. Now we're going to use a zero product property, set the first factor to 0. This is already solved. And then set the second factor to 0. All right, to solve the second one, just add 13 to both sides. And you have x equals 13. And the first one is x equals 0. So the solution here is x equals 0 and x equals 13. Okay, last one before we have you do some practice problems. Let's say you have the quadratic binomial 5x squared plus 30x equals 0. Okay, and the goal here is to solve by factoring. Okay, so what you're gonna do here first, we're gonna see if we can pull out the greatest common factor. All right, so let's break it down. We have 5 times x times x. If you break down 30, that's 5 times 2 times 3 times x. Now, is there a greatest common factor that we can pull out? Yes, there are. We have 5 and a 5 common. So you can pull out a 5 and a 5. And then you also have x and an x. So those are our greatest common factors. So factor them out. Remember, when you factor it out, you divide it out. So 5 and 5 got factored out. And then x's got factored out. And what are we left with? We're left with x plus 2 times 3, which is 6. Okay? Now this is a factored state of our quadratic binomial. Remember, you don't use the x scheme for binomials, all right? You just trinomials. Okay, now zero product property, we set both factors to 0. And in this particular case, none of them are in their solved state, like number 9. The first one was in the solved state. So we need to do some work. For the first equation, divide both sides by 5. And you get x equals 0. Okay, 0 over 5 is 0. And then for the second one, you subtract 6 from both sides, and you end up with x equals -6. Okay, so our solutions are x equals -6 and x equals 0. Okay, all right, so that's it. Now it's your turn. Alrighty, so here are the practice problems that we promised giving to you at the end of the presentation. We'd like you to solve the given quadratics by factoring. What we'd like you to do at this time is go ahead and pause the video presentation, try out the 10 problems, and then when you're done, click on the play button and we'll reveal what the answers are. Alrighty, welcome back. So hopefully you had a chance to try out the problems. Here are the solutions to the problems. Number 1, x is -1, -4. For number 2, x is -4 and x is -6. For number 3, x is -3 and 1. For number 4, x is -10 and 3. For number 5, x is 4 and 7. For number 6, x is -2 and 6. For number 7, x is -4, is -4 with a multiplicity of 2. Okay, so multi of 2. Number 8, x is 8 with a multiplicity of 2. Sorry, it's not 2, it's 3. So for number 8, x is 3. Let's fix that real quick. All right, so x is 3 with a multiplicity of 2. For number 9, x is 0 and 10. For number 10, x is -4 and 0. All right, so these are the answers. So we'd like to know how well you did in these practice problems. Let us know in the comment section below how well you did, okay? And if there are any of these problems that you like clarification on, just specify it in the comment section below and we'll be more than glad to assist you. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of quadratics, do give us a like. Your positive feedback is very valuable to us. If you have any questions or comments about what we covered in this tutorial or any factoring questions in general or quadratics question, just post it in the comments section below and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to other presentations such as this. We upload videos to our page on a weekly basis. Don't forget to look at the link in the description below for access to all our links and support resources. And do visit our website at mathgotserved.com for tons of resources to help you in your study of algebra. Thanks again for watching and have a wonderful day. Goodbye.